Hello and welcome back. In our previous tutorial, we did all the heavy lifting. We installed the local version of Voyant Server and our own private AI, Llama 3, using Ollama. We need to do a quick pre-flight check to make sure everything is running correctly. Let's get started. First, let's check on our Voyant Server. You should still have the terminal window open where you ran the java jar voyant-server.jar command. As long as this is running, your local server is active. To confirm, open your web browser and go to the address, localhost 8888. If you see the familiar Voyant Tools page, it means your local Voyant instance is up and running. Perfect. We'll leave this terminal window running in the background for the entire session. Next, let's make sure our Llama model is ready. The Ollama application should be running in the background. On a Mac, you'll see its icon in the top menu bar. On Windows, it'll be in your system tray. To be absolutely sure the model is loaded, we can use a quick terminal command. In a new terminal window, type Ollama ps. This command asks Ollama to show what processes are currently running. As you can see, it lists our Llama 3.2 model, which means it's loaded into memory and ready for our requests. Now, before we get to the code, there's one important web concept we need to understand called CORS, which stands for Cross-Origin Resource Sharing. You can think of CORS as a security guard. By default, for security reasons, a web page from one origin, like our Voyant server at port 8888, is not allowed to fetch data from a different origin, like our Ollama server at port 1,434. The browser's security guard stops it. To make our script work, we need to tell the Ollama server's security guard that it's okay to accept requests from our Voyant page. In the full written tutorial, there are instructions for configuring Ollama to allow this. If you run into connection errors later, it's almost always a CORS issue, and you'll need to revisit those setup steps. For most default installations, these should work out of the box, but it's a key concept to be aware of. Alright, our pre-flight check is complete. We've confirmed that both our Voyant server and our Llama model are running locally and are ready to be connected. We now understand the basic security model that our browser uses. Now, you can open the practice Spyral notebook prepared for this tutorial. This can be easily done by using your open file icon in Spyral menu and upload the notebook HTML file from your PC to Spyral. It might look quite overwhelming with a lot of code here. Don't be scared, you have seen most of these codes in previous videos, and I will take time to explain the basic programming concepts at play. Let's get started. Our first cell is all about setup. Here, we are creating two global variables. Remember from our fundamentals module, a variable is just a labeled box where we can store information to use later. The first variable, base0, stores the web address of our local Llama server as a string of text. The second, model name, stores the name of the AI model we want to use. By storing these in variables at the start, we can easily refer to them in later cells and change them in just one place if we ever need to. The second cell prepares a space in our notebook to show the AI's answer. It uses a conditional statement or an if statement. Think of this as a fork in the road for our code. This line asks a question, does an element with the ID result not already exist on our page? That means not. If the answer is true, if there's no result area yet, then the code inside the curly braces will run. And what does that code do? It uses JavaScript to interact with the DOM, or the underlying structure of the web page. It dynamically creates a new paragraph element, gives it the ID result, and adds it to our page. This is a great example of using a conditional to be safe. It ensures we always have a place to put our answer, but it only creates it if it's needed. Cell 3 is where we interact with you, the user. This first line uses a built-in browser function called window.prompt. A function is like a recipe. It's a command that performs an action. This one opens a pop-up box asking for input. The text we type into that box is then stored in a new variable called question. And just like in the last cell, we use another conditional to check our data. This if statement checks if the question variable is empty. If the user didn't type anything, it stops the script to prevent errors. For our demonstration, I'm going to input in a detailed question asking for a history of Nigeria. Our fourth cell prepares the message we're going to send to the AI. We're creating a JavaScript object. Think of an object like an index card with labeled fields. This is the exact format the Llama API expects. Notice the messages key. Its value is in square brackets, which means it's an array or a list. In this case, it's a list containing a single object that represents our message. We're using the variables we created earlier, window.modelName and window.question, to fill in the values. This cell's job is to package our request neatly, like putting a letter in a perfectly addressed envelope. So these first four cells are all about preparing ground by setting up our configuration. Cell 5 is the most important cell in the entire script. This cell does all the heavy lifting. It sends the request, processes the complex response, displays the answer, and, most importantly, saves the result as a new corpus that we can analyze with Voyant tools. Let's break it down. Before we send our request, the script does a little housekeeping. It defines a helper function called makeSelfVar_name. The purpose of this function is to take the name we provide for our output and make sure it's a valid name for a JavaScript variable. For example, it can start with a number. Then it uses another window.prompt to ask us what we want to name our output variable. For this demonstration, I'll name it Nigerian History. This is the name we'll use to access our new text corpus later. Now for the main event. This fetch function is what actually sends our request to the Llama server. We give it two main arguments. First, our base URL variable, which tells it where to send the request. Second, a configuration object that provides all the details. Inside this object, we specify that this is a post request because we are sending data. And most importantly, in the body, we include our AppRequestJSON object from cell 4, which contains our prompt and question. The JSON.stringify command converts our object into a string, which is the required format for sending. Because getting a response from a server takes time, the rest of the code is a chain of then commands. This is a pattern for handling asynchronous tasks. The first, then. Block acts as a checkpoint. It receives the initial response from the server and uses a conditional if statement to check if everything is okay. If there was a server error, it stops and reports the problem. If everything is fine, it proceeds to the next step, processing the response as JSON. The second that then, block receives the clean JSON data. Here we extract the actual text of the AI's reply, which is nested inside the data.message.content property. The rest of this section is about presentation. It creates a new, nicely formatted preelement and puts the AI's reply inside it so it's easy to read on our page. Now, this is the most important part of the entire script, where we connect everything back to our goal of doing humanities research. After we get the plain text reply from the AI, we use a special Spyral function, load corpus reply. This command takes the AI's plain text response and transforms it into a Spyral corpus object. This is a special type of object that the entire Voyant Tools ecosystem understands. We then save this special object in a new global variable using the custom name we chose earlier, in my case, Nigerian History. Take note that Nigerian History is now a proper Spyral corpus. We can now apply tools to it using the method chaining pattern we've learned. This command says, take my Nigerian History corpus and apply the corpus terms tool to it. We're also passing a configuration object to customize the output, asking for the top 25 terms sorted by their TF-ID of significance. When we run it, we instantly get a table of the most important terms in our new text. The power of this approach is that we can now run any Voyant tool with the same simple syntax. In cell 7, we're using the context tool to see every instance of the word military in its immediate context. And in cell 8, we're using corpus collocates to find the words that appear most frequently near the word president. Notice we're not writing any complex fetch commands or processing any JSON. All that hard work was done in cell 5. Now we can focus purely on the analysis, using these simple one-line commands to explore our text. The remaining cells demonstrate the incredible flexibility we now have. We can run a trends graph to see where general and president appear in the text. We can perform topic modeling to find thematic clusters of words. We can generate a serious word cloud, get a high-level summary, find repeated phrases, and even use the reader to do a close reading for a specific term like cool. Each of these is a different analytical lens, and we can apply them all to our AI-generated text with the same simple corpus.tool command. This is the power of the workflow we've built. So let's recap the entire journey. We started by installing local servers. We then used a 5-cell script to send a detailed prompt to a local AI. Our script processed the complex response and, most importantly, saved it as a new Spyral corpus. This final step unlocked the ability to use the full suite of Voyant's analytical tools on our new custom-made text, allowing us to seamlessly transition from AI-based text generation to in-depth digital humanities analysis. Now that you understand the code, you can adapt the whole script in this notebook to your own research, giving it the prompt that fits the LLM-driven corpus you want to build.